Remember that for binomial probability distribution, P of X is defined as n factorial divided by x factorial n minus x factorial p to the x q to power n minus x. But again, this formula is already built into your calculator. You don't have to use paper and pencil to calculate the probability. All you need is to identify the keyword and use your calculator. Before using the calculator, reset your calculator. Turn on your calculator, click on second plus. So second and plus. Find reset. My reset is on 7. Enter. You need to reset 2 things. You need to reset all RAM, then repeat these steps and reset the defaults. So for now, let us reset all RAMs. Click on all RAMs and reset. So we resetted all RAMs. Now you have to repeat these steps. Second, plus, find the reset and the defaults. And reset the defaults. Very good. So you don't have any built-in function anymore, and you can use your calculator easily. So let's see. We have an example here. The example says a particular surgery is performed on 8 patients. The probability of success is 90%. Question says find the following probabilities. Calculate A, the probability of X be exactly equal to 6. What's the meaning of that? When we see something like this, the interpretation is, what is the probability of exactly 6 successful surgeries? The keyword given to you is equal to or exactly. When you have keyword exactly, it directly refers to binomial PDF. Probability density function. To use that function, you need to click on second vars. Second vars. And then find binomial PDF. So second vars, and you need to move through these functions to find binomial PDF. Binomial PDF for me is located here. Enter. Now, when you click on binomial PDF, we need to enter some information. The number of tries. The number of tries, n, we know that we have 8 patients. This is the number of tries, 8. The second one is P, the probability of success. We know the probability of success is 90%. This is my P, probability of success. I'm going to enter it using decimal, everybody, 0.90. And finally, it says, what is your x value? My x value is 6. So let us enter 6 here and calculate the probability. Enter. If you're using your TI83, or if you're using your cell phone app, you need to enter them using parenthesis 8, comma, 0.90, comma, 6, and close the parenthesis. And then enter, and it gives you 0.1488. So the probability that exactly 6 surgeries are successful is about 0.1488 or 14.88%. That's how we find the probability when we have exactly. So the keyword exactly binomial PDF. Let us move on to next example. Suppose now the question says, hey, I want to know what is the probability that I have at most 6 successful surgeries. So first of all, this is the mathematical notation. The interpretation is, what is the probability that at most 6 surgeries are successful? So I'm going to write down at most here, so I can easily connect that with binomial CDF. At most 6 successful surgeries. When you have a keyword at most, it refers to binomial CDF. So we need to identify the keywords so we can use a correct function, CDF. When it says you have probability of at most, these are the steps that you need to take. You need to go to second, vars, find binomial CDF, and then enter n, which is 8, probability of success, and the exact value 6. CDF, cumulative density function. It adds all the probabilities before 6 to probability of 6. So it actually counts the probability that x is equal to 0, add it to probability that x is 1, add it to probability that x equals to 2, plus the probability x equal to 6. You don't have to calculate each one of these separately. Your calculator has built-in CDF function. It means that it automatically adds them all together. So let us continue. Second vars, let us find binomial CDF. Make sure you don't select PDF. PDF only works when you have exactly. We are using at most, so it is CDF, the second function here. Enter. The number of tries, n is 8. Probability of success, 90%, it's fixed. The x value that we're going to enter is 6. So let us calculate. It's 0.1869. So the probability that x is less than or equals to 6 is 0.1869, or about 18.69%. So far, we have exactly as the keyword. We have at most as the keyword. Now we're going to move on to next keyword. Fewer than, less than. C. So now suppose I ask you to find the probability that x is less than 6. What's the difference between these two? In B, I have equality. 6 is already involved in this calculation. But in C, I don't have any equality. X is less than 6. Or equivalently, you can write it as probability that x is less than or equals to 5. It means that when you're using P of x less than 6, you can follow what you did before, but the number here is now changed into 5. So question, what is the probability that fewer than 6 successful surgeries are there? So second vars, binomial CDF 8.90, and now remember 6 is not included, so 6 minus 1 or 5. The probability that x is less than 6 is about, we have to use our calculator, am I right? Second vars, find binomial CDF. The number of tries is 8. The probability of success, 90%. But for our x, instead of using 6, we have to use 5 because 6 is not included. Now let us calculate the probability. It is going to be 0.038. 0.038 or 3.80%. As you can see, these two probabilities are different from each other. We expect that this one includes the probability of 6, but this one doesn't include the probability of 6. So far, we discussed exactly, at most, and fewer than. So for fewer than, as you saw, you're using again binomial CDF. They have to do a little bit of algebra, one value less. 2 more scenarios. Now in this question, I ask you find the probability that x is more than 6. More than. What is the probability that we have more than 6 successful surgeries? More than. The keyword here is more than. Guys, be careful here. We have a very important algebra step that students usually forget. Here, you're going to select 1 and then subtraction, minus. 1 minus. 1 represents 100% or the total area. What I'm going to do, I am going to take the whole area. This is 100% of the area for 1. And I'm going to subtract whatever is on the left-hand side. So I'm subtracting this one. 100% of the area for 1 minus this little area, which is x less than equals to 6. This is the probability that x is less than equals to 6. It gives me the probability that x is larger than 6. So 1 minus, so I'm going to write it down here, 1 minus. Then I'm going to go to second vars. I'm going to find binomial CDF. And I'm going to enter n probability of success. Guys, remember that I'm just subtracting whatever is on the left-hand side. 6. So let's see what do we have. 1 minus second vars. Let me find binomial CDF. Trials 8. 90% probability of success, and 6. Let's see. It gives me 0.8131. So the probability that x is more than 6 is about 0.8131 or 81.31%. More than 1 minus binomial CDF. 1 minus binomial CDF. And the last scenario is at least. Now, if I ask you to find the probability that x is at least 6, it means that x is 6 or 7 or 8. What is the probability that at least we have at least 6 successful surgeries? At least you have again 1 minus binomial CDF. In this case, x larger than equals to 6 is going to be on the right-hand side. So I'm going to subtract the probability that x is less than 6. So I'm going to subtract the probability that x is less than or equals to 5. This guy is now the probability that x is less than or equals to 5. So the steps that we're going to take is 1 minus second, then vars, binomial CDF, 8, 90%, and here you have a 5. 1 minus, don't forget 1 minus second vars. Now find binomial CDF. 8, the number of tries fixed. 90% the probability of success fixed. And here the x value that you're going to enter is 5. Let's see what do we have. It gives us 0.9619. So the probability that we have at least 6 successful surgeries is about 0.9619 or 96.19%. These are all the things that you need to do the computation for a binomial probability distribution. You have 1, 2, 3, 4, 5 different scenarios. Each one of these scenarios is associated to one keyword. If you have exactly, you must use binomial PDF. If you have at most, you must use binomial CDF. We're not changing the number because it's already included. As you can see, I have 6 here. if my keyword is fewer than, I have to subtract 1 from the given value. Fewer than, 6 is not included. I have 5 and before 5. If it says more than, I have to do a little bit of algebra. 100% minus binomial CDF. In that binomial CDF, I have the exact value. It says larger than 6. So we are subtracting whatever is before 6. And 6 is also included. And in the last scenario, you have at least. It means that the value is included and more. 1 minus binomial CDF.